Welcome to today's tutorial. Today we are going to discuss about the integration by method of substitution. So generally, if it is in calculus 1, so you will have the integrations of this form like this: integration g dash x f gx dx. That means the composition function, which is the inside function, you have the derivative is inside the whole integration. So in such cases we will solve the problem. In such cases we will solve the problem like this. So substitute u is equal gx, then we will apply the derivative here by chain rule. So du is equal g dash x dx. So therefore the given integration g dash x f of g of x dx can be rewritten as f of g of x g dash x dx. Now we substitute it. G of x is equal u, so it will be f of u, and then g dash x dx, we got it here du. So our new integrations is become f of u du. So everything you will get it here f of u, and this f of u have the antiderivative, say f of u. So therefore you will convert it, the whole integrations, to f of u in such a way that you know already the antiderivative, and then you will get the antiderivative capital F u plus c. Now f u is the our assumption variable, but our original variable was x, so therefore your answer will be f of g of x plus. So now we'll solve some numerical example to get better idea. So our first question is example involving the algebraic expression. So if the question involve only the algebraic expression, how we'll solve it here? So here first example is we have x square root of x square plus 5 dx. Now we know that square root of x square antiderivative, but here is the expression is x square of 5, so we don't know any antiderivative of square root of x square plus 5. So therefore the problem is square root of x square plus 5. So therefore we will try to reduce that problem and solve it or adjust it in other parts. So here you need to substitute it. T is equal x square plus 5. So this will gives you square root of t, and you will know the antiderivative of square root of t. So now if you substitute it, then you have here dt is equal to x dx. So now I will write it. So this is I is equal, I given integration x square plus 5 dx. This is equal, I rewrite it. You can avoid these steps, but here I am writing to understand you clearly. So this is square root x square 5 plus 5 is our assumptions t. So this is equal to square root t, and x dx, from here you will get it x dx is equal dt over 2. So this is dt over 2. So this is equal half integration of square root of t dt. So this is equal half So integration of square root t is t to the power 3 over 2 over 3 over 2 plus c, which is, we can write it as 1 over 3 t to the power 3 over 2 plus, and then we'll go back here, t equal x square plus 5, so it will be 1 over 3 x square plus 5 plus. Our next example is 4x square plus 3x to the power 25 and 16x plus 6. So here we have to identify that which one you will substitute it and which will help you to compute the integration. So here you will see, if we substitute this one, so there is a chance that it will become x and constant number. So therefore that expression also is here. So our first priority is to put t is equal 4x square plus 3x. So this implies dt is equal 8x plus 3 dx. So I denote this integration is I to simplify it. So therefore I is equal 4x square plus 3x, we substitute as t, so it will become t to the power 25. Now 8x plus 3, so this one can be written as 16x plus 6. This can be written as 8x plus 3. So 8x plus 3 dx will be dt. So it will be 2 dt. So this is become 2 t to the power 25 dt. So this is equal to t to the power 25 is 26 over 26 plus c. So this is equal 1 over 13, and the answer is t. So substitute back t is 4x square plus 3x. So you substitute it here, 4x square plus 3x to the power 26 plus c. Next problem is integration of x square root of x plus 5. So therefore here also again the problem is the expression under the square root, which is x plus 5. So therefore we will first try to substitute this one. So let's t is equal x plus 5. So this will gives you dt is equal dx. So our I is equal, so square root of x plus 5. So this is becoming a square root of t. Dx is become dt. But there is a problem is x square. So we cannot write the x square here. We need to change everything in the form of t. So how we can do that one? So therefore from here we need to check it. So t is equal x plus 5. So this implies x is equal t minus 5. Here we will write t minus 5 whole square dt. So we have first simplify this. So t minus 5 whole square root t. So this is t square minus 10t plus 25 square root t. So this is equal t to the power 5 over 2 minus 10, t to the power 3 over 2 plus 25 t to the power half. So this is equal t to the power 5 over 2 minus 10 t to the power 3 over 2 plus 25 t to the power half dt. So this is equal, so 5 over 2 plus 1, 7 over 2. So we can write it directly like this, 2 over 7 t to the power 7 over 2 minus 10 This is 3 over 2 plus 1, which is 5 over 2. So it is 2 over 5 t to the power 5 over 2 plus 25, and then say 25 t to the power half. So half plus 1 is equal 3 over 2. So 2 over 3 t to the power 3 over 2 plus 6. Now simplify and substitute back. So 2 over 7 t is x plus 5 minus, this is 4 7 2, this is 4, this is x plus 5 5 over 2 plus 50 over 3 3 over 2 plus 6. Put theta is equal tan 2x. Then we have the derivative here. D theta is equal to secant square 2x dx. So therefore our I is equal half, then secant square 2x dx is d theta, and this is equal to square root of theta. So this is equal half, and this is 2 over 3, 3 to the power 3 over 2 plus c. So this is 1 over 3, and this is 10 to the power 3 over 2 2x plus c. Now here we have one important question, is that from the antiderivative table you know the integration of sine x dx and integration of cosine x dx. But what about the other trigonometric functions? So this is equal minus cosine x plus c. This is equal sine x plus c. But we don't know the integration of tan x dx, integration of secant x dx, integration of cotan x dx, and integration of cosecant x dx. So these integrations will be basic in calculus 2, but calculus 1 you should know how to get the integration of such functions. So here first we will consider the tan x. So here as we are discussing the substitution method, so we don't know what will be the integration. So I is equal, we need to convert the tan x to the sin x and cosine x dx. Then we will substitute theta is equal cosine x. This implies d theta is equal minus sin x dx. So therefore I is equal minus, for this minus there is minus, sin x dx is d theta, and this is theta. So this is equal minus ln absolute value of theta plus c. Since we don't know theta is negative or positive, so we always put absolute value, and then we'll substitute back theta. Theta is equal cosine x. So this is minus ln cosine x plus c, which can also be written as ln cosine x to the power minus 1 plus c, which is equal ln secant x plus c. So therefore you have to memorize this formula. Tan x is equal ln secant x absolute value plus c, and in similar way you will get it here, the cotan x. So integration of cotan x dx, you will get it ln sin x plus c or minus ln cosecant x plus c. Next example is involving the exponential and logarithm functions. So here you will substitute it and we will see that what you need to substitute it. Here is the problem is e to the power x, because we know the x square plus 4. We know that d dx of tan inverse x is equal to 1 over 1 plus x square. So we can adjust some way like that. So for that we have to put it here, put t is equal e to the power x. So this will gives you dt is equal e to the power x dx. So therefore the numerator part will adjust with dt, and then our integration is reduced to this is dt, and here it will be t square plus 4, which is equal to 1 over a. So we know that 1 over x square plus a square dx is equal to 1 over a tan inverse x over a. So in this case our a is equal to, so here 1 over 2 tan inverse t over 2 plus c. So this is equal half tan inverse t, t is equal to the power x over 2 plus c. To solve this integration, first we need to revise it in this form, dx over e to the power 3x plus e to the power minus 3x. This is equal, we need to write it here, e to the power 3x over e to the power 3x whole square plus 1 dx. We use this one, that e to the power minus 3x is equal to 1 over e to the power 3x. So e to the power 3x plus e to the power minus 3x is equal to e to the power 3x plus 1 over e to the power 3x, which will be e to the power 3x whole square plus 1 over e to the power 3x. So now we'll substitute it e to the power 3x. T is equal to the power 3x. This implies dt is equal t to the power 3x dx. So therefore I is equal 1 over 3 integration it is dt over t square plus 1. So this is equal to 1 over 3 tan inverse t plus c. So this is equal to 1 over 3 tan inverse e to the power 3x. Here is evaluate 1 over x ln x dx. So we need to substitute whose integration we don't know. We don't know anything about the any antiderivative of ln x. So therefore first we'll reduce that one, and for that we'll put it t is equal ln x. So this implies dt is equal 1 over x dx. So our integration is reduced to, this is dt dx over, so you can, if you separate them, you can write it here ln x and dx over x. So this dx over x is equal dt and 1 over ln x. So ln x we substituted t, so it is t. So therefore this derivative is ln t, absolute value of ln t. So here also we don't know ln x is positive or not. So it is absolute value of ln t plus c. So this is equal ln, now t is ln x plus c. That's all. Okay, our next part is that method of by definite integration. So if you have a definite means limit a to b definite integration, then how we solve it? So there are two methods. Method 1, solve integration g dash x f of gx dx as before, and say the answer is integration g of x f of g of x dx is equal f of gx plus c, but we neglect the c for definite integration. So therefore a to b g dash x f of gx dx is equal f of gx, and limit is a to b, so answer will be f of g of b minus f of g of a. Method 2, so first substitute u is equal g of x, then du is equal, so let u is equal gx, then du equal g dash x dx, and here our limit is for x, so we'll change it. So when x is equal a implies u is equal g of a, lower limit. Upper limit, so x is equal b implies u is equal g of b. So our new integration is I is equal, so you have here g of a, g of b, f of u, d. Now if you know the antiderivative of f, so let's it is capital F, so f of u limit is g of a, g of b. So this is equal f of g of b minus f of g of, that's 10. So here we'll solve this problem. So this is exactly we'll solve as before, and we can take two methods as we discussed before. So we can solve this problem by two methods. So let's have method 1. Consider integration r square square root of 8 minus r to the power 3 dr, the indefinite form, and then here put t is equal 8 minus r to the power 3. So this will gives you dt is equal minus 3r square dr. So therefore I is equal minus integration r square dr is dt. So this will gives you r square dr is equal minus 1 over 3 dt. So it will be minus 1 over 3, and here r square dr will be dt, so it will be square root of t dt. So this is minus 1 over 3 and 2 over 3 t to the power 3 over 2. We are neglecting c because it's a definite integration. So this is equal minus 2 over 9, 8 minus r to the power 3 to the power 3 over 2. So therefore integration 0 to 2 r square root of 8 minus r to the power 3 dr. So this is equal minus 2 over 9, 8 minus r to the power 3 to the power 3 over 2, limit is 0 to 2. So this is equal minus 2 over 9, and this is 8 minus 8 to the power 3 over 2 minus 8 minus 0 to the power 3 over. Now we have method 2. In this method also we'll proceed almost same way. So put t is equal 8 minus r to the power 3 dt is equal minus 3r square dr, and then you will get it r square dr is equal minus 1 over 3 dt, and here you will get it the limit. So when r is equal 0 implies t is equal 8, and r is equal to implies t is equal 0. So our I is now reduced to the limit for t. So lower limit is 8, upper limit is 0 minus 1 over 3, and this is square root t dt. So this is equal minus 1 over 3, and if we have a minus we can change it the order of the limit, so it can be written as 1 over 3 0 to 8 square root 8 dt. So 1 over 3 2 over 3 t to the power 3 over 2, limit is 0 to 8, so it is 4 over 3, sorry, this is equal 2 over 9, 8 to the power 3 over 2, and the other part is 0. Our next question is 0 to pi over 4 tan square t secant square t dt. So in this case we need to substitute it tan t. So we'll use the method 2 only. So let's substitute theta is equal tan t. So this implies d theta is equal secant square t dt. And now we'll check the limit. The lower limit, lower. So t is equal 0 implies theta is equal tan 0 is equal 0. Upper, t is equal pi over 4 implies theta is equal tan pi over 4, which is equal 1. So therefore our I is equal 0 to 1, and this is theta square d theta. So it is 1 over theta, theta to the power 3, limit is 0 to 1, so 1 over 3. Solve this integration, we will substitute the denominator part. So let t is equal 9 plus x to the power 3, then you have dt is equal 3 x square dx. So this implies x square dx is equal 1 over 3 dt. And now we'll take the limit. The lower x is equal minus 2 implies t is equal 9 plus minus 2 to the power 3, so which is equal 1. And upper limit x is equal to implies t is equal 9 plus 2 to the power 3, so 8 17. So therefore our integration is reduced to 1 to 17, and this is 1 over 3 1 over t square dt. So this is 1 over 3 integration 1 to 17 t to the power minus 2 dt. So this is 1 to 3 and this is 1 over t 1 to 17. So 1 over 3 1 over 17 minus 1. So minus 16 over 50. Next integration is cosine 2x 3 plus 4 sine 2x. Here we'll substitute t is equal 3 plus 4 sine 2x. This implies dt is equal 8 cosine 2x dx, and this implies cosine 2x dx is equal dt over 8. Now x is equal 0 implies t is equal 3 plus 4, 0 is equal 3, and x is equal 2 pi implies t is equal 3 plus 4 sine 4 pi, which is also 0, so this is equal 3. So therefore our integration is reduced to 3 to 3 and 3 to 3 dt over 8, and this is 1 over square root t, which is equal 1 over 8 3 to 3 dt over square root 3. We know that from limit, same limit, the answer will be always 0. Question is cosine t 1 plus sine square t dt. So in this case again we will substitute it sine square t only. Sine t is equal theta, so this implies cosine t dt is equal d theta, and the limit t is equal 0 implies theta is equal sine 0 is equal 0, t is equal pi over 2 implies theta is equal sine pi over 2, which is equal what? 1. So therefore the I is equal 0 to 1, and this is d theta 1 plus theta square, so which is equal tan inverse theta, and limit is 0 to 1. So tan inverse 1 minus tan inverse 0, so this is pi over 4. Next question is 0 to 3 1 over 9 minus r square. So this can be solved by the substitution also, but we'll use this integration dx over square root of a square minus r square, which is equal 1 over a sine inverse x over a plus c. So therefore here clearly direct answer it will be I is equal 1 over 3 sine inverse x over 3, limit is 0 to 3. So this is 1 over 3 sine inverse 1 minus sine inverse 0. Sine inverse 1 is pi over 2, so this is 1 over 3 pi over 2, so pi over 6. The next question is e to the power x 1 minus e to the power 2x dx. So here you will put it t is equal e to the power x. This implies dt is equal e to the power x dx, and the limit x is equal ln half, t is equal e to the power ln half, which is equal half, and when x is equal 0, t is equal e to the power 0, which is equal 1. So our I is equal half to 1 dt over 1 minus t square, so which is equal sine inverse t, limit is half sine inverse 1 minus sine inverse half. So this is equal sine inverse 1 is pi over 2, sine inverse half is pi over 6, pi over 3.